Watch, learn, and we'll be a star freelancer. 24-hour live stream. Save time and money. 100 plus free videos and free books with source code, materials, and resources. Starfreelancer.eu.
Welcome back. In previous step, we have successfully created the ingress manifest with the default backend option. So now we are going to go ahead and then deploy that and then test it. So let's go back to our terminal here and go to 08 new and 0801 and not 01. So we'll go to 0802 and inside 0802 ALB ingress basics. So we'll run the command kubectl apply -f and 01 kube manifest default backend. So this should create the Nginx deployment for us, and also it should create the node port service, and also it should create the ingress service for us. So now we can see all three things were created: deployment, service, and then ingress. So let's go ahead and then verify the deployment and pods first, and then we will move on to the ingress. So I'll clear kubectl get ingress. Why I came to ingress? So we'll first do the deployment, right? Verify the kubectl get deploy. So all these things are created in the default namespace. That's the reason we really don't need to mention -n kube system or -n default namespace. So both are same. So you can say default and it should be the same thing. So you can see app1 Nginx deployment is ready. One by one is ready. So we'll say get pods, and we should see that app1 Nginx deployment and that respective pod got created successfully, and then it is running. So now we'll also see kubectl get svc, and then it will list the app1 Nginx node port service for us, right? You can see 80:32291 is the node port service, node port of our respective service. So now the next thing here is we need to say kubectl get ingress. So this should list the ingress service for us, whatever we have created, which is ingress Nginx app1, and this belongs to the class my AWS ingress class, and here is the address app1 ingress. This is the name of my load balancer, whatever we have provided here. See, app1 ingress hyphen some dynamic id dot us east1 dot elb dot amazon aws.com, right? So now let's come back here to our load balancers. So in EC2, right? So go to services, and in EC2, so let's go to load balancers, and in load balancers, so you should find that app1 ingress. The name of my load balancer is app1 ingress, and its DNS name is app1 ingress hyphen so and so so and so, and its state is currently active. And you can see in the description lot of information about that load balancer. So the listeners, it has created the HTTP 80 listener by default, and also if you see inside it, right, so it should have the default backend. So this is the default backend, requests otherwise not routed. So it is added as a default backend, and it is going to some target group here. So we'll go and then verify the target group now. So let's come back here and go to target groups here, right? And in target groups, you will find here K8s default app1 Nginx. So this is something, the older one. So I'll just remove this. So this is unassociated one, user management one. See, none associated. I'll just delete it. So this is coming from previous demos. So I'll remove that. And now if you see here, K8 as default app1 Nginx is there, and its port 32291. This is the node port. So let's come back here and verify the same thing. See, in kubectl get svc, your app1 Nginx node port is 32291. Same is also added here, which means your node port service, your node is registered here with that respective port. So and protocol is HTTP, and target type is instance. So if you remember, we have discussed about the traffic mode, right, which is nothing but instance and then IP traffic modes. So here by default, right, so by default, if you don't define any traffic mode, so then the target type is going to be instance. And if you define it, you can define the target type as instance or IP. So let's go to annotations here, and I'll say IP, or I can search for target type. Yeah, you can see here ALB ingress Kubernetes IO target -type instance or IP. And if you see here, instance mode will route traffic to all EC2 instances within the cluster on node port opened for your service, right? So service must be of type node port or load balancer to use the instance mode. And IP mode will route traffic directly to that respective pod IP. And another important thing to note here is, so let's go to that target type. And then come here, and you see at the top, right? So this is the default. So what is the default for that is instance. So which means by default, whether you define this target -type as instance or not, by default it will take the instance, and explicitly you need to define for IP if you want to need IP, right? So that's about the target type. So now let's go inside that, right? And see, this is the target type instance and protocol version, all these things are good, and this is associated to the load balancer app1 ingress, that is good. And total targets, 2 targets and healthy, right? So you can see both instances registered successfully here. So we have 2 nodes, and then both nodes registered successfully here. Irrespective of whether that pod is present in which node, it doesn't need that, right? Why? Because your node port service is spanned across all the nodes. So that means whether you have the pod in which node is not a consideration here. So if in your private node group in Kubernetes, if you have 50 nodes, all 50 nodes will be added here. So that's about the instance mode, traffic instance mode related thing. We can also see here the health status is healthy, and we can also go inside the monitoring and go to health checks and review the settings. So protocol you have provided HTTP, and path you have provided as /app1index.html, and traffic port you have provided, and all these things. Interval, if you remember, we have provided the 15 seconds. See, 15 seconds. So all those things, whatever we have provided in the annotations for the health check settings, so all these things are available here. So now let's go back here and also go back to our GitHub. Here, describe ingress controller. So just review and understand more about it. So let's copy here and go here. kubectl describe ingress, and ingress name is ingress-nginx app1. And if you see here, right, in the ingress, name, namespace, address, and in the default backend, you see default backend is the value it is provided here, which means in host there is no paths, only the default backend related information is provided here. So just make a note of these things, and then go ahead and then review these things in the next demo, how it comes. Why? Because in the next demo you will use the rules, and there it will say /* go to this. So like that you are going to see. So currently you have the default backend here, but in the next demo we are going to see this differently. So for that purpose only I am showing the differences, which means whatever the rules you have defined in the ingress, so those things using the kubectl describe ingress command, you can review them directly here, whether they were successfully created in a right way or not. In the annotations also you can see in detail, and also you can see there are no error events here, successfully reconciled. So now let's come back, and we have also verified the target groups and all those things. So now let's go ahead and then access the things. So let's come back here and say kubectl get ingress, and you will get the name. This is the address. This is the same as the DNS name of your load balancer. So let's come back here and go to the load balancers, and in the description section search for whatever you have copied here, both are same. So you can give this, and the root context page is nginx default one should be displayed, and our core page which we need to test is app1/index.html, and here you will see welcome to Stack Simplify related page, application name app1, right? So this completes the demonstration of Ingress using the default backend. So if you want to review the logs of your respective pod, or if you want to review the logs of your load balancer controller also, you can review all those things. So now we'll go ahead and then clean up whatever we have created, and if you want we can also review once the kubectl get pods -n kube system, and if by any chance if your ingress is not working, at that point of time it is always good to go to that respective load balancer controller pods and also verify. So I'll say kube system and logs -f. Mine is working, so we really don't need to go here, but I'm just trying to show you, right? And see in both the pods if you are seeing any errors or anything, right? So here there is nothing related to that, all are info only, just for our additional things. So now let me clear this, and I'll say kubectl delete -f and 01, which is kube manifest default backend, so that we are removing the deployment service and ingress service whatever we have created, right? So now this should also delete the load balancer whatever we have created here. So let's come here and refresh, right? See the load balancer whatever app1 ingress we have created is gone now. So let me close these things, and your deployment and service also cleaned up. So if I say kubectl get all from default namespace, only the default Kubernetes service and also the whatever the ingress class we have created, those should be displayed. See service Kubernetes default cluster IP service for our Kubernetes is displayed here, so nothing is present here. Or you can say get pods or get svc or get ingress, everything is cleaned up whatever we have created. So in our next lecture we are going to focus on demo 2, where we are going to define the routing rules. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. As part of step 7, we are going to define the ingress manifest with ingress rules. So before going there, we need to understand ingress path types in detail. So if we go here, we have 3 types of path types available for us from ingress perspective. So one is implementation specific, and second is exact path type match, and the third one is prefix match. So implementation specific path type is nothing but for that respective controller. So with this path type, matching is up to the controller implementing the ingress class. So example, we are using the AWS ALB related ingress controller, and in this implementation if we have any specific path types defined related to AWS, so we can use with implementation specific, and by default it is going to be implementation specific if we don't define the path type argument in our respective rules. So implementation can treat this as a separate path type or treat it identically to either prefix or even the exact path types. And exact is nothing but it need to match exact URL path with case sensitivity, and prefix is nothing but matches based on a URL path, prefix split by /. Matching is case sensitive and done on a path element by element basis. So if we take the examples, we'll get the clarity on prefix and then exact. And implementation specific will be by default, but as we said here, so it might consider it as either prefix or exact based on the implementation that controller is implemented. So we are going to use prefix. Why? Because which is loosely coupled and easily we can use it. So let's take the examples here and understand more about it, the differences between the prefix and the exact, and then how it is going to work. So example, in prefix, right, you have defined in your Kubernetes manifest, right, as /. So in the request path, whenever you are accessing via browser, all paths are allowed. That's the reason it says matches yes, which means this is true. It works. So whenever you define slash with path type as prefix, all paths are allowed. And the next thing is exact. So whenever you provide the path type as exact, so before going and implementing these things, so let's see this here, right? So in the rules, HTTP paths, you can see path, whatever the path you define, and the path type is prefix or exact. So like this you are going to define the stuff. So let me copy this, right, and come back to our ingress manifest, right? So where is it? In 02 cube manifest rules, and in ALB ingress basic, so API version, kind, metadata, annotation, all are same as previous ingress manifest, right, till spec and ingress class name. So only thing now we are defining here is rules. Under rules we are defining the HTTP rules, and under that you have the paths, and the path we are going to use is a root, right, which means all paths should be allowed, and path type is prefix. And backend, in backend the service name we need to provide is, so we'll go to here, and this is same as again 0101, which is Nginx App 1 deployment and node port service. It is absolutely same. So I'll bring that from there and come back here and provide the name here, and number is 80, right? So once we have defined this, so now let's go back here and understand more about these things. So you said slash so that all paths are allowed, so which means whenever you access with slash app1 slash index.html, it is going to work for us without any issue. So now let's come back here, and if you provide the, if you define here in the path, right, slash foo, right, and if you access it with slash foo from your browser, right, so http:// some stack simplify.com/foo, and you also defined here the foo, so then it is going to work. And when you define it as exact, right, in the same way whenever you define it as exact, and when you access it when you define it as foo, and when you access it as bar, and it is going to fail. So that's the thing. So like this we need to understand, this is the request path, which is nothing but from the browser whatever you are accessing, and this is like whatever you are defining here, and the kind is nothing but the path type you are defining. So for us, I'll roll back this one to this one, and I will remove this. Okay, and now let's see, same thing for exact/foo, and then you will access with adding the trailing slash. Again it is going to fail because exact is exact, that's all, and exact/foo/ if you access and with only /foo from the request path which is from the browser, then it is also going to fail. So which means exact is only for critical specific implementations which you know thoroughly, right? But most of the time prefix is loosely coupled and you will be able to easily use it, right? If you see, /foo works for /foo, and also with trailing slash also it works, and here also with prefix with trailing slash if you put it, and in your path if you define /foo/ with the trailing slash, still it is going to work with and without when you access it via browser, and prefix with /AAA/BBB, and if you try to access with additional B here, it is not going to work. Why? Because it is not going to add any string additions here. It is like /AABB and it should be /AABB, that's all, right? But if you provide /AAA/BBB, and also if you request via browser also /AAA/BBB, it is going to work. So like this you can define, you can see all these things how it is going to be, all the samples provided here. So these are generic ingress things, prefix whatever you see, and for exact also. So you can define these things, and accordingly most of the things are covered here, so you can use it and then implement your rules. So now let's come back here, remove this, and the path is /prefix backend and everything is good. So now let's go back to our GitHub, right, and then run the kubectl apply now. So let's come back here, and we are in 0802 ALB ingress basics, And if you see here, we should have something called 01 and then 02 related folders, right? 01 and 02. So I'll say kubectl apply -f 02 kube manifest rules, right? So this should create the Nginx deployment and Nginx service and Nginx ingress service, right? So now we can go ahead and then see kubectl pods, and our app1 Nginx pod is created. And if we run the svc, it should provide us the app1 Nginx node port service, which is with 30134 is the node port service. And we'll also run the kubectl get ingress, and you can see ingress Nginx 1 is created, and this is the URL for that. And let's go here to load balancers, refresh, right? And you can see the name of it is app1 ingress rules. So why? Because I have given the name for this as ingress rules. This is a ingress rules demo, so the load balancer name I have given as app1 ingress rules, right? And here are the listeners, and it is in the state as provisioning. If you go to target group and open that, right, so you can find both the worker nodes were registered here with port 30134. So whatever we have defined here, right, so 30134, whatever it has automatically generated for this node port service. So now let's wait for this load balancer to come to active state so that we can go ahead and then test it. So we can see here our load balancer is in active state. So we can open here and we can see there is no default backend for us, right? And we can see path is /star, and for that /star goes to our app1 Nginx default target group, and inside the target group we have our respective node port service related things registered, right? So both nodes were registered with 30134, right? So now let's see, both are healthy. So now let's come back here and take this, copy and run this, right? And you should see that we should get the welcome to Nginx root context page. Why? Because we said /star, and I'll also say /app1/index.html, and my app1 should be accessible now. So let me close these things, right? So now what we are going to do is we are going to also verify kubectl describe ingress, and ingress name is ingress Nginx app1, and we'll see the rules here how it is defined, right? So let's wait for it. See, the default backend is default backend HTTP, and nothing is there here in the default backend. And in the rules you can see for the / this is the node port service it is pointed to. So this is the difference between the previous default backend one. There you have seen the node port service here, and now you are seeing the node port service here for the app1 Nginx. So this is good. Now what we are going to do is we'll do a small test. Even I didn't document that step here, but we will do that, right? So let's come back here, and in 0802, right, we will change this to /app1. So we have learned about that prefix things a lot here, if you remember, right? So let me open this documentation, ingress path types, and we have defined /app1, which means earlier whatever we are accessing here. So let's come back here, and this should go away, which means whatever the root context, under the root context, whatever we are accessing, this welcome to Nginx page. So after this change, it should go away. So let's see. So we are saying that only anything with /app1, then only go to app1 Nginx node port service. So which means under the root context, whatever is there, it should fail, right? So now we have saved this, and if you come back here, right, and see /foo with prefix, right, it will allow for /foo and anything with /foo/star, right? So that is the importance of prefix. So let me run this change now. So I'll come back, kubectl apply -f and then 02 kube manifest rules, and this change should take place. And now if I say kubectl describe ingress nginx app1, so you should see the rules here, which is /app1. And if you go back here to rules here and refresh them, right, or if you go here, so it should say /app1 or /app1/*. So now let's come back here, kubectl get ingress, right, and copy this, right, and go to the browser and try it. So this is coming from the cache. So let me go here. See, it is failing in the incognito window. And if I say /app1, and it should app1/index.html, so this should work. So very clearly tested the use case which we have discussed here, which is this one, path /foo. So /foo and then /foo/ will be allowed when your path type is of kind prefix. So let me roll back this change here so that you can test it later, right? So with default one. So now let's come back here and go ahead and then clean up. So I'll come back here and clean up. kubectl delete -f02 kubemanifest rules. So this should remove the deployment service and also the ingress service, which is the application load balancer, whatever it has created. So let's wait for all the resources to get deleted. So one important thing to note here is verify whether your ingress is deleted successfully or not. Why? Because application load balancer is costly, and by any chance if it didn't get deleted properly, then it is going to charge us heavily, right? So for that purpose, verify with get ingress command here, kubectl get ingress, and also go here and also say refresh in your load balancer section, and also verify there are no load balancers, so that we'll not have any unexpected charges for us. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this section, we are going to implement Kubernetes ingress context path based routing in application load balancer. So let's see the network design for this entire implementation. So we already created a VPC, and inside a VPC we have public and private subnets. We already created a EKS cluster control plane and also EKS private node group in the private subnets. In addition to that, we also installed the ingress controller. So now we are going to deploy 3 apps. So for those 3 apps, we are going to have those 3 deployment manifests and node port service manifest. So those are nothing but app1 node port service and app1 deployment, app2 node port service and app2 deployment, and app3 node port service and app3 deployment. And we are also going to define an ingress service with context path based routing rules. So wherein we are going to define a rules like /app1 goes to app1 node port service, which eventually goes to the app1 pod, and /app2 context path goes to app2 node port service, which eventually goes to the app2 pod, and anything with root context goes to app3 pod via app3 node port service. So as a user, whenever I access my application with ALB DNS URL / with root context, so the request will go to app3 pod via node port service and ingress service, and the rule is /. And when you access your URL with /app1, so it comes to your ingress service and it checks for the rule /app1 and it routes to app1 node port service. From there it will reach the app1 pod, and same applies to the app2. So whenever user accesses with /app2 as the context path in the browser, request comes to the ingress service and validates its rule for /app2. The configured service is going to be app2 node port service, so it will go there, and from there it will go to app2 pod. So this is what is going to happen whenever we implement the context path based routing. So far we have seen the network design for ingress context path based routing using the AWS resources. So you can see EKS cluster control plane, public subnets, private subnets, worker nodes, all these things. Also see the same architecture in a different way using the Kubernetes objects, how it is going to work inside the Kubernetes cluster, right? So you have in AWS cloud, you have created the AWS EKS cluster, and in EKS cluster in the kube system namespace you have installed the ingress controller. So ingress controller related deployment, which eventually creates the ingress controller pods, and also you have the ingress webhook service. So now whenever as a Kubernetes admin using kubectl client, whenever you deploy the Kubernetes objects, right? So in those objects, whenever you deploy ingress service related Kubernetes object or a resource, so this ingress controller keeps watching the K8s API server, which is EKS cluster API server, for finding any ingress services deployed. And if it finds any ingress services deployed, immediately it is going to create the ingress service for us. And this ingress service is nothing but whenever this ingress service is created, its equivalent AWS application load balancer is created in the AWS cloud. And this ingress service already has context path based routing rules inside that, and those also will be defined inside this ingress service, and equivalent routing rules also will get created in the AWS application load balancer, right? Now one important thing is, so using the K8s admin using kubectl client only, you will also deploy the node port services and also deployments for your Nginx app1, app2 and then app3. And whenever user accesses with the /app1 context, so the request will go to app1 Nginx app1 pod. So via ingress service and the rules, it will cross check the rules and it will go to that app1 service if the context path is app1, and go to that node port service, and from there it will go to the pod. Same applies for app2 and same applies for the root con. Another important thing which we need to be aware of is AWS application load balancer and ingress service are not two different objects. In other lines, so it is like AWS application load balancer is not proxying its request to ingress service. So both are combinedly a single object. So for depiction purpose, in EKS cluster you call it as ingress service, and in AWS cloud you call it as AWS application load balancer. So whenever as a Kubernetes admin, whenever you provide the ingress service Kubernetes manifest for K8s API server, when this ingress controller watches and creates the ingress service, so this ingress service is nothing but it creates equivalent AWS application load balancer object. That's all. So which means users, whenever they access anything /app1/index.html or anything, so this entire thing is a single object, and from here the request goes to the your respective node port service, and from there it will go to your respective application pod. But anything under this red boundary is called a single object. So this clarifies that there is no proxy between AWS application load balancer and ingress service. Next. So this completes the introductory part of EKS ALB ingress context path based routing. In our next lecture, we are going to go ahead and then practically implement the same use. I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. Let's go back to our GitHub repository, and we are in section 0803 ALB ingress context path based routing. So as part of introductory section, we already discussed about the network architecture, what we are going to implement, and also the rules we are going to define for app1, app2 and then app3. So as part of this process, we are also going to move our health check path annotation at the service level, which is nothing but inside the node port service. So why we need to do that? is because in the ingress service we can define a health check path if it is common for all the services or all the applications whatever you are load balancing. So but per application you have different health check path, then that respective application health check path URL should be configured inside that respective node port service. So in that line we are going to move the health check path related annotation to the node port service of that respective application, app1, app2 and then app3. And let's go back to our step 2 here, which is review Nginx app1, app2 and app3 deployment and then service. Service is nothing but the node port service. So let's go to our Visual Studio Code here, and we are in section 0803 ALB ingress context path based routing, and we are in 08 new ELB application load balancers, and inside that 0803, and in kube manifest folder we have 01, 02 and then 03 files. So 01 Nginx app1 deployment and node port service, 02 Nginx app2 deployment and node port service, and 03 Nginx app3 deployment and node port service. And in app1 deployment and node port service, so the standard deployment pattern and standard node port service related manifest will be there here. Only differences, right? Only differences we are going to have here primarily are related to Kubernetes deployment, which is container image name, and for Kubernetes node port service the health check URL path. So let's come back here, and this is the app1 Nginx deployment, and replicas we are going to create one pod here, and the selector match labels you have the app1 Nginx as the label here, app equal to app1 Nginx. So the same thing need to be defined in your node port service related selector app1 Nginx. So now when you come to here in the image, right, in the pod template spec, right, so stack simplify / kube Nginx app1 will be your app1 related Nginx image. And when you go to the node port service here, the health check path for app1 is /app1 index.html. So this is the thing. So this is the one which we need to move to those respective node port services. So need to add health check path annotation at service level if we are planning to use multiple targets in a load balancer. So accordingly we have ensured that for the app1 Nginx we have added the health check path in our node port service. So now if we go back to 02 Nginx deployment, so here also you will see this is kube Nginx app2 will be my image here, and health check path also it is /app2 index.html, and remaining things which is nothing but this is a app2 Nginx, so its label selector match label will be app2 Nginx, and its selector in the node port service also going to be app2 Nginx, right? So now let's go back to our 03 Nginx app3 deployment, and if you see here the image name is kube Nginx. So this is a root context. Here there is no specific context like /app1 or /app2 inside this Nginx image. So it has a root context, and in the root context you are going to have the index.html. So now let me also change this to app3. So everywhere you should see app3. So selector match labels app3 Nginx, and here also in the node port service also you'll see selector and the label is app and app3 Nginx. And another important thing we need to cross check here is the health check path. So here we are going to check the root context /index.html as my health check path for my app3 application. So these three are the applications we are going to deploy, and using ingress service, right, we are going to do the context path based routing. So now let's come back here, and this completes the review of step 2. In our next lecture we are going to review step 3, which is create ALB ingress context path based routing Kubernetes manifest. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's go to the file 04 ALB ingress context path based routing.yaml, and let's define the ingress service here. So let's go back to our Visual Studio Code here, and we are in 04 ALB ingress context path based routing. So this template we have took from the 0802 ALB ingress basics. So where we have written 02 ALB ingress basic with rules, we have copied that and we have changed it the way we need it. So the first thing what we need to change here is, let's go back here to context path based routing, and the name of my service, ingress CPR demo, context path based routing demo. And also the load balancer name we are going to give here is CPR ingress. And now let's come down here and change these rules as per our needs, right? So the first things first is, we are going to implement 3 apps, app 1, app 2 and then app 3. So we'll put this as 3 times the paths. And the first path is app 1. So for app 1, it need to go to app 1 nginx node port service. So if we want to verify the name of our node port service, go to 01 nginx app 1 deployment, and this should be app 1 nginx node port service. So let me close this, come back here and put the same thing here, right? And now the second one is app 2. And for app 2, the service name is going to be app 2 nginx node port service. So go to 02 and get the name from here and come back here and put that. And for the root context, right, it is going to be app 3. So let's go to 03 nginx app 3 and get the name of the node port service, app 3 nginx node port service, right? So let me put this here. So now you can see that for whenever the request comes with /app1, it goes to app1 nginx node port service. From there it will go to app1 related pods. And when request comes with /app2 in the context path, URL /app2, so then it goes to app2 nginx node port service, and from there it will go to that respective pod. And same applies for app3 nginx node port service. Anything other than app1 or app2 context, anything comes, so it goes to app3 nginx node port service. So let's come back here and move on to the next step. Next step is to deploy all the manifests and test it. So let's go back to our terminal here, go into 08 new, right, which is 08 new ELB application load balancers, and inside that we are going inside 0803, which is ALB ingress context path based routing. And if you see here, we should have the kube manifest folder, and if you go inside and verify that, you should find 01, 02, 03 and then 04. 04 is ALB ingress context path based routing YAML. So let's come out of this and then be inside 0803, right, and say kubectl apply -f and then kube manifest. So this should deploy 3 applications related deployments, node port services, and also create a ingress service for us. So you can see app1 nginx deployment and app1 nginx node port service is completed, and app2 nginx deployment and node port service is created. And same line, app3 nginx deployment and app3 nginx node port service. And finally, it also created the ingress CPR demo related ingress service. So now let's come back here and verify the application pods and then node port services. So kubectl get pods should provide us the app1, app2 and then app3 related nginx pods created here, and one by one they are ready and then running, no issues. And we'll also verify the kubectl get svc, so which is services, and it should display as the node port services, app1, app2 and then app3. And now let's come back here and verify the ingress load balancer related service. So we'll say kubectl get ingress, and this should display the CPR ingress CPR demo related ingress service, and it is using the ingress class my AWS ingress class, and this is the address it has created, the load balancer DNS name with port 80. So let's go back here, and if we want, we can also review the rules inside this respective ingress service. So we need to say kubectl, right, describe ingress, and this is the ingress service name, ingress CPR demo. And let's see the rules whatever we have implemented in our ingress service manifest were created as expected or not. So you can see here /app1 goes to app1 nginx node port service on port 80, and /app2 context path goes to app2 nginx node port service, and / goes to app3 nginx node port service. And we didn't define any default backend, so it's nothing here, right? So now let's come back here, and you can see successfully reconciled, and there are no error events also here. And these are the annotations, whatever we have specified, those were displayed here. So now let's come back here and verify the load balancer controller logs, right? So you can go here, kubectl-n kubesystem get pods will provide us the load balancer controller. And if we want to review the logs also, we can review these things, kubectl-n kubesystem, right? And you can say logs -f, and for both the pods you can verify the logs if there are any errors in those things because of the ingress service whatever you have deployed. So we really don't need to do this, but it's for our additional learning. You can see here registering the targets and so on. So you can see all the logs in detail and understand little bit more. Ideally not needed, so I'll remove this and I'll say clear, and we'll go to verifying our application load balancer on AWS management console. So let's come back here, and in EC2 let's go to load balancers, and in load balancer CPR ingress related load balancer is created. And in basic configuration, so you can find the DNS name. So this DNS name should match whatever we got here, which is kubectl get ingress, right? Ingress and 110.43.11.640, 110.43.11.640. So this is good, and state of the ingress service or the application load balancer is active, which means we can access in the browser and test it. So we'll go to that a little bit later. First we'll go to the listeners, and we can see the port 80 listener is there, and under this listener we'll see the what all rules it has been defined. So we'll go here and you'll find something like /app1, and whose priority is topmost. The way how you define the priority is the /app1 will be the first priority, and you can see it is going to forwarding to some app1 nginx related target group, and /app2 or /app2/* should go to app2 nginx target group, and /* goes to app3 nginx target group, right? So now let's come back here and go to the target groups, right? And you should find 3 target groups, app1, app2, and then app3, and all are using the node port service, which is nothing but whatever we have defined there. So let's open one of the target group and verify that app1 nginx target group, right? So total it has 2 targets, which means why? Because we have 2 worker nodes running. So those 2 worker nodes were registered here with those respective node port services, and then respective node port service, and you can see both from both of the nodes it is healthy, the pod is healthy for us. And now if you see here, the health check path should be /app1 index.html, and you can see it is healthy, right? Even though you have created only one pod, but the node port service is span across all the nodes. So which means in the worker nodes, whenever you are using the node port service, right? So it is span across all the worker nodes. In a worker node group, you have created 10 nodes. So those 10 nodes will be registered here with that respective node port service related port, which means even though you have created only one pod and it is running in any one of the worker node, but the concept here is node port service will be, or the service, Kubernetes service will be spanned across all the nodes. In that line, you can see here all those nodes will be registered here. Now let's come back and verify app2 related one and its health check path. Those also healthy, both nodes registered, and you can come back here and app2 index.html is the path for that, and it is working as expected. And this is the app3 nginx, which will be with root context /index.html, and it is also healthy. So why we are verifying the health check paths here very specifically is, so whatever we have defined at the service level annotation, right, here health check path has been populated here successfully or not in the ALB application load balancer, we are cross checking. So why? Because we said that we have defined the context path based routing related ingress service, but we didn't define the health check path here, but we defined at the service level here. Whether it came here successfully or not, we are cross checking, and it came successfully here, and we can see for all the three paths whatever we defined in the node port service annotations, so same is populated here. So now let's come back, right? So we verified the target groups, health check paths and everything. So now finally we will go ahead and then access the application. So how we are going to access it? So we can take the DNS name from here, from the load balancer description here, or we can go here and copy this address. And for app1 it is going to be, we are going to say /app1/index.html, and you can see it should be coming online now. So welcome to Stack Simplify, and application name is app1, and app1 is in light green color. So now we'll go to /app2 and index.html, and this should show us app2 related things, and you can see this is in different color. And now finally we'll also access the root context /index.html, right? So whenever we access the root, so it should be the default app, which is welcome to Stack Simplify Kubernetes fundamentals demo. Application version is v1. So this is app1, so this is app2 under the app2 context, and this is the default app3 one with the root context /index.html, and you can see all three are of three different colors. So the requests are going to three different apps for us. And if you want to further also verify, so you can go to kubectl get pods, and for each pod, right, kubectl logs -f, and then you can go to those pods and then verify the logs. Let's wait for it, and you can see /app1 index.html, the health check path also using the same thing. So that's the reason you can see the 192.168.91.189, all these things are coming from our load balancer. Right here you can see this is app1. So whenever you check the logs for your app1 related pod, so it is saying 200 for app1 index.html. And if you see for kubectl get pods, and if you check for app2 kubectl logs -f and app2 pod, you should see the health check for app2 running there. So the logs for app2 index.html, and it is also 200. And also we will say one more here, kubectl get pods, right? And we will also see for our app3, which is, it should have the health check path for root context. So let's say logs -f, and this is the app3 nginx pods. Come back here and verify this, and it should have /index.html. Get /index.html, and it is coming from the ELB health checker. So this is the thing, and you can see one more here. This is not ELB health checker. So whenever we have accessed it from the browser, so Intel Mac OS X 1015, which is my Mac OS, there it has accessed, and it is the public IP of my mission 124.123.166.3, right? So this is the thing. So this completes the use case, which is implement the context path based routing using ingress service and then test it, right? So in our next lecture, we are going to test the context path based routing order. How important is the defining the order for our context path based routing. So I'll see you in the next lecture. Until then, bye bye. Thank you.